Hi, welcome to RC Studies. So in this class, we'll learn about refractive index, the part of refraction of light at plane surfaces. So before that, we'll learn about refraction. We'll recall refraction. Refraction means when the light ray enter from one medium to another medium, that is from, for example, this is air and this is water. Air, water. So when light ray enter from air to water, so this is the separation of two media. This is called interface of two media. So this light ray travel by bending at the interface because of changing of speed. So the speed of light is different in different medium. So if we draw a perpendicular line to this interface at the point of incident, this point is called point of incident. So this is called normal at that point, denoted by the letter N. So and this ray is called incident ray, and this ray is called refracted ray, and the angle between normal and the incident ray is called incident angle, and the angle between refracted ray and the normal is called angle of refraction, denoted by the letter R. So and here you know that speed of the light is greater in air than the water. So that's why this air is called rarer medium and this water is called denser medium. So this air is called rarer when compared with the water. So air is also called as denser when compared with the vacuum. The denser and rarer terms are the relative terms. So here air is rarer and water is denser medium. When the light ray enter from rarer medium to denser medium, it can bend towards the normal. See this, it's coming, bends towards the normal. What is the actual path of the light? If there is no water, this is the actual path of the light, but it bends towards the normal because of changing of velocity, decreasing of speed. And if the light ray enter from denser medium to rarer medium, it deviate away from the normal. So this is the incident angle here, this is the refracted angle. So this ray is moving from denser medium to rarer medium. That's why at the interface point of incident, it can deviate from its path away from the normal. So this is the actual path. This is the actual path of the light, but it deviates away from the normal. So what we have learnt, when the light ray enter from rarer medium to denser medium, it can bend towards the normal, and when the light ray enter from denser medium to rarer medium, it bends away from the normal. So remember these points. Let's learn about refractive index. So refractive index means, you know, the speed of the light in the vacuum is how much? Speed of the light in vacuum is 3 into 10 to the power of 8 meter per second. So it's very important. Speed of the light in vacuum. So speed of the light in vacuum is how much? 3 into 10 to the power of 8 meter per second. So this is the highest speed of the light. So in which medium? Vacuum. So light travel in the vacuum with highest speed, maximum speed, and just consider any other medium. So speed of the light in the given medium, any other medium, in the given medium is taken as V. So just whatever it is, any medium, air, water, glass, whatever it is. So speed of the light in vacuum is C. Speed of the light in given medium is V. So the ratio of C to the V is called refractive index. So absolute refractive index, which is denoted by the letter N. So what is this refractive index? Refractive index N is equal to speed of the light in vacuum by speed of the light in the given medium. The given medium, that means speed of the light in vacuum is C and the speed of the light in the given medium is V. So C by V is the refractive index. And units, what are the dimensions of this refractive index? Refractive index units, so which having no units, because this is the ratio. So ratio of the same physical quantities, this is velocity, this is speed, this is also speed, that's why which having no units. So refractive index having no units, and this is what kind of refractive index? Absolute refractive index. Absolute refractive index. This is absolute refractive index. This is denoted by letter N. Refractive index of some media. Refractive index of vacuum is refractive index of vacuum. What is the refractive index of vacuum? Refractive index of vacuum means refractive index of vacuum means velocity of light in vacuum by velocity of light in vacuum. This means 3 into 10 to the power of 8 by 3 into 10 to the power of 8 is equal to 1. Refractive index of vacuum is 1 and the refractive index of air is 1.0003 and the refractive index of water is 1.33. Refractive index of kerosene is 1.44 and the refractive index of diamond is 2.42. So refractive indices of some medium is given here, and so just observe what is the refractive index of water. 1.33, that's enough. There is no units. So refractive index of kerosene is 1.44. Here remember one thing, this refractive index is depending upon the optical density of the medium. Optical density, not mass density. Mass density is different from the optical density. Here observe, refractive index of water is 1.33. Refractive index of kerosene is 1.44, which is greater kerosene. Here, if the refractive index is high, the speed of the light in that medium is low. If the refractive index of the medium is low, the speed of the light is high. So, in which medium speed of the light is high? Here, water is 1.33, kerosene is 1.44, which is greater refractive index. This is the greater refractive index. That's why velocity of light in kerosene is less than that of the water. So, speed of the light in the water is greater than kerosene. But here kerosene is less mass density than the water. That's why it's float on the water. But here kerosene having high optical density than the water. That's why its refractive index is more than that of the water. And next we'll learn about relative refractive index. What is, so this is the absolute refractive index. Absolute refractive index means the ratio of the speed of the light in vacuum to the speed of the light in the given medium. And relative refractive index, refractive index of glass is 3 by 2. Then find the speed of the light in glass. You know refractive index formula, n is equal to c by v. Refractive index is equal to speed of the light in vacuum by speed of the light in the given medium. So speed of the light in given medium is, from this formula we can write speed of the light in given medium v is equal to c by n. You can write like this. So v is equal to c by n. That means velocity of the light in the given medium is equal to nth part of the velocity of light in the vacuum. So nth part of the velocity of light in vacuum is velocity of light in the given medium. So here c means, you know c value. What is c value? C means velocity of light in the vacuum is equal to how much? 3 into 10 to the power of 8 meter per second. And n means refractive index of the glass. How much? 3 by 2. So therefore speed of the light in the glass is equal to c by n. That is equal to, c means 3 into 10 to the power of 8 by n means 3 by 2. So that is equal to 3 into 10 to the power of 8 into 2 by 3. 3 cancel. So 2 into 10 to the power of 8 meter per second. So therefore speed of the light in the glass is equal to how much? 2 into 10 to the power of 8 meter per second. Refractive index is depending on nature of the medium and the wavelength of the light that we use. Refractive index. This is the comparison of two media. The ratio of the speed of the light in the one medium to the another medium is called relative refractive index. Absolute refractive index means that is comparing with the speed of the light in vacuum. But here two media. So just consider two media. Any other? Consider this is water, this is glass. So this is one medium and this is another medium. So the speed of the light in water is taken as v1 and the speed of the light in glass is taken as v2. And the refractive index of the relative refractive index of the glass with respect to water. Whose refractive index? Glass relative refractive index. So relative refractive index of the glass with respect to water we can write as, this is the second medium. The refractive index of the absolute refractive index of the glass is n2 and absolute refractive index of the water is n1. Here relative refractive index we can write the relative refractive index of the second medium with respect to first medium. We can write like this: relative refractive index of the second medium with respect to first medium is equal to So whose refractive index? Refractive index of glass. I want refractive index of glass with respect to water. So speed of the light in the first medium, that is water, by speed of the light in the second medium. So whose related refractive index? Second medium refractive index. So that means speed of the light in first medium is V1, speed of the light is in the second medium is V2. So the relative refractive index of second medium with respect to first medium is V1 by V2. So speed of the light in first medium by speed of the light in second medium. So we can express relative refractive index in absolute refractive index indices also. So just V1. So just divide numerator and denominator by C. V1 by C, V2 by C. So divide the numerator and the denominator by C. So V1 by C, V1 by C means what is the absolute refractive index formula? N is equal to C by V. So C by V, that means 1 by N is equal to how much? V by C. So V by C means V1 by C means N1. So V2 1 by N1 by V2 by C is equal to 1 by N2. So 1 by N1 by 1 by N2 is equal to N2 by N1. So what is the relative refractive index of the second medium with respect to first medium? N2 by N1. So relative refractive index of the second medium with respect to first medium is equal to V1 by V2 and is equal to N2 by N1. So this is very, very important to derive the Snell's law. So this is about relative refractive index and absolute refractive index. Absolute refractive index means the speed of the light in vacuum by speed of the light in given medium, whatever it is. Whereas the relative refractive index means speed of the light in the first medium by the speed of the light in second medium is the relative refractive index of the second medium.